Hey everyone, so today we're going to be looking at how to name ionic compounds, specifically binary ionic compounds. Now, binary ionic compounds are going to be substances that contain just a metal and a non-metal, two different elements bonded to each other. So let's go ahead and get started. So first off, when you're naming binary ionic compounds, you want to name the metal as is. So for example, if it's Fe, it's iron. If it's Ca, it's calcium. If it's Mn, it's manganese. Specifically for the metal, and this is only for the metal, if it is a transition metal, that area on the middle of the periodic table, lead, which is Pb, or tin, which is Sn, you must use a Roman numeral to indicate the charge of the ion. And you figure out the charge of the ion based on what it's bonded to. You always name the nonmetal with the IDE ending. So for example, if we have NaCl, pretty common example here, Na is the metal, and that is going to be sodium. We name it as is. Then you ask yourself, hey, is Na a part of the transition metals? It's not, and it's not Pb or Sn, so I do not need to use Roman numerals to indicate the charge. We're going to name the nonmetal with the IDE ending. So it's chlorine, but we're going to change it to the IDE ending, which is chloride, sodium chloride. So let's go ahead and move on. Let's try a couple examples here. So here's the list of ionic compounds that I want to go ahead and name. If you feel comfortable doing this, go ahead and skip through this part of the video and try naming these compounds. MgO is an ionic compound. It's a metal and a nonmetal. Mg is magnesium. We're going to name magnesium as is. Magnesium is not a transition metal, so we do not need the Roman numerals. And then O is oxygen. So we're going to change the end to IDE. So it's magnesium oxide. CuCl is going to first start off with Cu, which is the metal, and this is copper. We're going to name this as is copper. And copper is a transition metal, so we need to leave room for the Roman numerals, but it's going to be bonded to chlorine, so it's going to be copper something chloride. Now, based on the non-metal here, chlorine, if you look on the periodic table, has a charge of -1. So in order to counteract or balance out with that, copper must have a charge of +1. So the Roman numeral is going to be 1, copper 1 chloride. Next, we have K3P. K is potassium. Potassium is a metal, but it's not a transition metal, so I do not need to use the Roman numerals here. P is phosphorus, so it's going to be potassium phosphide. Now, as far as this goes, it's really easy to say phosphoride, but that doesn't exist. We don't use the OR as part of this, so it's just going to be phosphide. Next, we have FeBr3. Fe is the metal called iron, and iron is a transition metal, so we will need to include a Roman numeral here. We'll come back to that in a second, but it looks like it's bonded to bromine, so it's going to be iron something bromide. Now, bromine has a charge of -1, since it's in the 7th column on the periodic table. Because there are 3 of them, iron must have a charge of +3 to counteract that bromine's -1 charge. There are 3 bromines, so that will make a neutral ionic compound. Last but not least, we have PbO2. Pb is our metal lead. Now, while lead is not a transition metal, it is one of the 2 metals that we need to include Roman numerals for, so we know it's going to be lead something oxide. Now, the charge of oxygen in an ionic compound is -2, and there are 2 of them. So this is going to be lead 4 oxide, and the Roman numeral for 4 is IV, so lead 4 oxide. Excellent. So pretty much with all of the binary ionic compounds, it's metal as is, then non-metal with the IDE ending, and you have to consider if that metal is a transition metal or not. So moving on, we want to make sure we're comfortable with writing the formulas for ionic compounds. As far as this goes, I want to remind everyone that even though ionic compounds are composed of charged particles, the ions in those compounds are charged, the ionic compound itself is neutral. So when we go ahead and write these formulas out, when we go ahead and write these formulas out, we want to make it such that the overall charge on the entire thing is 0. Ionic compound formulas are represented such that the cation's charge cancels out with the anion's charge. So how can we go ahead and do that? Well, let's go ahead and look at calcium chloride. Now, based on the periodic table, calcium has a charge of 2 plus, and the chloride ion has a charge of 1 minus. That means in order for them to come together in an appropriate ratio, I would need 1 calcium for every 2 chlorines. So once again, in order for it to be neutral, I would need 2 things with a negative 1 charge for every 1 thing with a positive 2. Now, there is a cool trick that I can use for determining the formulas for ionic compounds, and this is based on the charge of those ions. The quantity of the charge for an ion will indicate the amount of the other ion required to neutralize it, to make it the overall ionic compound not have a charge. So for example, let's look at strontium nitride. Strontium is in the second column, so it has a charge of 2 plus. Nitride has a charge of 3 minus. If you look at the value, the quantity 2 and 3, that will tell you the amount of the other ion that you need. So it looks like we will need 3 strontiums and 2 nitrogens in the formula for strontium nitride. The formula should be Sr3N2. So let's go ahead and try a couple of these out here. We'll use the cross-down method for determining the formula for these. So vanadium 1, this is my favorite part about Roman numerals. If you see a Roman numeral, it tells you the charge of it. Vanadium 1 would be V1 plus. Bromide is the ion Br1 minus. That means that I have a 1-to-1 ratio of vanadium and Br, so it should just be VBr. Magnesium chloride, so magnesium is in the second column, it's going to have a charge of 2 plus. Chloride is in the seventh column, it's going to have a charge of 1 minus. When the ions form a compound, it's going to be MgCl2. Notice that I take the number here and use it as the subscript on the other ion. The subscript for Mg would be 1, the subscript for Cl would be 2. Lithium phosphide would be Li has a charge of 1 plus. Phosphorus has a charge of 3 minus. Once again, I get these from the periodic table, their placement on the periodic table. When I bring these together, this will be Li3P. And then the last one here is manganese 4 nitride. Manganese 4. Remember, manganese 4 tells us that manganese has a charge of 4 plus. Nitride, being in the third column, has a charge of 3 minus. Using the cross-down rule, it looks like we're going to be Mn3N4. Mn3N4. And we're using the quantity here to indicate the amount of the other one there. So now the last thing I want to point out while we're going over this is a few exceptions or special circumstances to the rules. And that would be in a situation like magnesium oxide, where the cross-down rule doesn't quite work. So let's go ahead and look at this. Magnesium, being in the second column, has a charge of +2 as an ion. Oxygen has a charge of -2 because it's in the sixth column. Because they have the same charge, you only need one of each in order to cancel out the charge. So if we were doing the cross-down method, the formula that I would create for this would be Mg2O2. If you have an ionic compound, the ratio that they come together is always going to be one of the smallest whole number ratios, so it's 1-to-1. The formula for magnesium oxide in this situation would be MgO. So let's go ahead and look at these last two examples here. We have lead for oxide. Once again, we like the transition metals. We like the ones with Roman numerals because it pretty much just tells us what the charge is. We don't have to look it up at all. Lead has a 4+ charge. Oxygen has a 2- charge. based on this ratio, I would need 2 oxygens for every 1 lead. PbO2 would be the appropriate ratio between lead and oxygen ions in the lead oxide compound. Aluminum nitride, so aluminum is in the 13th or 3rd column, depending on how you're looking at the periodic table. Al3+, it is in the 3+ column. Nitrogen has a charge of 3-. Luckily for this, it's a 1-to-1 ratio. So Aln would be aluminum nitride. So don't forget, there is a graphic organizer that follows along with this. There is also an instructional worksheet to practice writing the formulas for ionic compounds online. Let me know if you have any questions and have a great day.